Today we are going to discuss humidity. Humidity is water in the air. To be precise, it is a measure of the amount of water in the air. Water is added to the air by the process of evaporation. Evaporation is a process we have discussed in the past, but in case you have forgotten, this is when water turns from a liquid form into a vapor form. Relative humidity is a term that you are definitely going to need to remember. Relative humidity is the amount of water in the air compared to the amount of water the air could possibly hold. Think about if you were holding a glass of water that is half full. Well, that's not all the water that the glass could hold. It has the possibility of holding more water. Humidity values are usually given as relative humidity. For example, if the air is holding half of the water it could hold, the relative humidity is 50%. If the air is holding all of the water it can hold, it is saturated, and the relative humidity is 100%. If the air is holding no water at all, the relative humidity is 0%. And if it is holding a quarter of the water it could hold, then the humidity would be 25%. Now, let's think about this. If the air is saturated and the relative humidity is 100%, it's probably raining outside. After all, the air can hold no more water and the water has to go somewhere. If the air is holding no water and the relative humidity is 0%, well, we're probably not going to have any rain. Actually, there's a 0% chance of rain. But on a day when the relative humidity is 50%, you might feel it a little bit when you're outside running. Now, temperatures depend on, the temperature outside depends on how much water the air can hold. Let's look at this chart. To the left side of the screen, you will see the vertical title called Amount of Water Vapor. The horizontal line at the bottom of the screen shows temperature. Notice at negative 20 degrees Celsius, how much water can the air hold? That's right, it can hold very little water at all. But now let's look at 30 degrees Celsius. The air is able to hold more water. The warmer it is outside, the more water the air can hold. The colder it is outside, the less water the air can hold. This is why in winter you go outside and your lips get dry and your skin gets dry and cracked. It's because there is very little water in the air. If the air is saturated, it is holding all the water it can hold. Warm air expands and can hold more water vapor than cold air, so it takes more water to saturate the warm air. If the air is saturated, its relative humidity is 100%, and if the temperature drops, precipitation will occur. There are two main factors that affect relative humidity. 1, the amount of water. If you increase the amount of water in the air by adding it due to evaporation, the relative humidity will go up. The second factor is temperature. Since warm air can hold more water than cold air, if you lower the temperature, the relative humidity will go up, even if you don't add more water. This is why when a cold front collides with a warm air mass, we have rain. Water capacity of air at different temperatures. Let's look at the circle to the far left of your screen. This circle indicates a temperature of 10 degrees Celsius. At 10 degrees Celsius, the water vapor indicates a 100% relative humidity. But what if the temperature increases to 20 degrees Celsius? Well, we still have the same amount of water vapor in the air, but now the relative humidity is at 52%. What if the temperature increases again and it increases to 30 degrees Celsius. The amount of water vapor in the air is still the same. However, the relative humidity is now at 28%. Measuring humidity. Relative humidity is measured using a psychrometer. A psychrometer is made of two thermometers. One is covered with a wet cloth. The wet cloth in the picture to the top right of your screen is actually a tan color. When air moves over this wet cloth, evaporation occurs and lowers the temperature on that thermometer. If you compare the temperature on the two thermometers, you can get an idea of the relative humidity. We actually have these thermometers at school, though we call them sling psychrometers because there are several different types, and that's what we have. When determining relative humidity, we use a chart similar to this. To find the relative humidity, you must locate the column head that is equal to the difference between the wet bulb and the dry bulb readings. Remember, the wet bulb is the bulb that has the wet cloth on it. The dry bulb is the thermometer that did not have a cloth on it at all. So you take these two bulbs and you subtract and find the difference between the readings. If there is a 3-degree difference, after subtracting, you would move over to the number 3 at the top of your screen. Then you're going to locate the row head that equals the temperature reading on the dry bulb thermometer. So we would look at the reading at the dry bulb, and let's say the reading was 8 degrees Celsius. Okay, the value that lies where the column and the row intersect equals the relative humidity. You can see a psychrometer below. So let's say the difference between the wet bulb and dry bulb readings was 3 degrees Celsius, and the dry bulb reading was at 8 degrees Celsius. We follow these lines and discover that the relative humidity is at 63 degrees. Take a moment and look over this chart. Okay, let's determine relative humidity. Example 1. The dry bulb equals 14 degrees Celsius. The wet bulb equals 10 degrees Celsius. Therefore, we take 14 minus 10. 14 minus 10 is 4. So first we're going to look at the dry bulb reading. Second, we find the difference. And now we're going to look at this. Here we go. Since the difference is 4, we look at the 4 at the top of the screen. Because the dry bulb reading is 14, we look at the 14 to the left of the screen. Let's see where they intersect. The relative humidity is 60 degrees Celsius. Is 60%. Does it seem easy? Let's see if you can figure it out on the next try. The dry bulb is 4 degrees. The wet bulb is 3 degrees. Take a moment and do the math. Remember to subtract. The difference between the dry bulb and wet bulb is 1. So we will find the 1 at the top of our chart. There we go. Now we're going to look at the dry bulb. The dry bulb is at 4. So our relative humidity is 85%. Okay, let's try another one. The dry bulb is 6 degrees Celsius. The wet bulb is 60 degrees Celsius. What is the difference? Please tell me you can do this math. I'll be concerned if you can't. What is the relative humidity? The relative humidity is 100% because there is 0% difference. It's definitely going to rain outside. So let's discuss condensation. We have discussed condensation in the past, but let's review it one more time. Condensation is the process by which a gas, such as water vapor, becomes a liquid. Condensation will occur when the air is saturated or has a relative humidity of 100%. The air can't hold any more water vapor, so the water condenses out of the air. This most commonly occurs when moist air is cooled or comes into contact with a cool surface, which is why when you wake up in the morning and go outside, there's a lot of dew and water on the ground because the temperature dropped overnight. Dew point. This is a vocabulary term that you will definitely need to know. The dew point is the temperature at which condensation will occur. The dew point is the temperature the air must be in order to be saturated. Remember, cooling the air makes it unable to hold as much water vapor, so water will condense out at a certain temperature. This occurs all the time whenever you have a cold glass of water or lemonade. The ice makes the air near the glass cooler, and it reaches its dew point. Cool air can't hold as much moisture, and condensation occurs. No, the water is not seeping out from your glass and suddenly forming on the outside of it. This is water that is from the air. Cloud formation. As we've discussed before, clouds form when water vapor condenses on condensation nuclei. Condensation nuclei occurs when solid particles in the air solid particles in the air that water can condense on. This is what causes clouds. Smoke particles, ash, dust, pollen, pollutants, all of these are things that water condensates on, which forms our clouds. Okay, let's do a review of clouds. Cirrus clouds are made of ice crystals. They're wispy airs that are seriously high in the air. Remember, Sirius is seriously high. Cumulus clouds. Remember, cumulus means to heap upon. These always look like cotton balls. So remember, cumulus, cotton balls. Stratus clouds. Every time you hear stratus, think a sheet. Stratus, sheet. These are layered clouds, usually low on the ground, such as fog. Okay? So stratus, sheet. Stratus, sheet. Cumulonimbus. Anytime you hear the word nimbus, it means rain. So remember, nimbus, rain. Nimbus, rain. Cumulonimbus indicates storms, usually thunderstorms, so be careful. These are the stages of a cumulonimbus cloud. Okay. Take a moment and look over this picture. This indicates how clouds are formed. The sun heats the air, causes water to evaporate and rise. As it evaporates, it starts to cool as it rises in the air and starts condensing around the condensation nuclei, and then it forms clouds. You will need to know these types of clouds. Make sure you take time to study, and remember, Sirius is seriously high. Stratus is like a sheet. Cumulus are cotton balls, and nimbus always means rain. Also take time to familiarize yourself with charts such as this. You will need to know how to calculate relative humidity.